All right, good afternoon, everyone. What I'm going to be looking at is, does chiropractic care alter sensory processing? And really to kick this off, I want to go back in time, because we're going to look at some of the research that's been done over the last 15 years or so. So let's go back 15 or 20 years. Think about what was happening back then. Where was chiropractic back then? Where was technology back then? We didn't have iPhones. Can you believe that? No iPhones. I didn't know what you had for dinner last night because we didn't have Facebook. Members of the chiropractic profession at either end of the spectrum, they didn't like each other. Could you believe that 15 years ago? Crazy. And we didn't really know all that much about how chiropractic care influenced the nervous system. We had a few studies. They kind of showed you adjust someone, we see some reflex changes. There's the odd study that showed a bit of change in sensory processing. The odd study showed a bit of change in motor processing or motor control. We didn't have an awful lot though. So this was the scene when Heidi started her PhD. So Heidi, Bernie, that's what they're faced with. They wanted to understand, how did chiropractic care influence the nervous system? And Bernie's introduced this stuff to you nicely, which is great. One way of looking at sensory processing is with these things called SEPs, so somatosensory evoked potentials. And Bernie's already given you the rundown. You stimulate a nerve, so the median nerve, and you can look at how that afferent volley from that stimulation is processed as it goes through the nervous system. And this picture up here, this is a lab in Denmark. The gorgeous looking fellow on the right, Imran, he's going to be presenting next. He's part of our crew. This is Dina Lalich. She's a wonderful scientist, according to Heidi, the world's best scientist. She's not a chiropractor, she's a bioengineer. So bioengineer, not a chiropractor. She was really running this experiment. And that guy in the back there at the computer, that's me. I was probably playing spaceys, making out that I actually knew what I was doing, but this was purely for the picture. So what these guys are doing here is, this is an EEG cap. So there's like 64 electrodes in this cap, and we can measure EEG over the brain. So they're using syringes full of electrode gel, so we can pick up EEG over the brain of this guy here who was a part of our experiment. And what you get with these SEPs is, as Bernie said, you stimulate the nerve many times. So it could be hundreds, could be 1,000 times. And you have these little chunks of EEG activity here after the stimulation, and you press a button on a computer and stuff happens, and we see squiggly lines. And when I say stuff happens after you press a button on a computer, Heidi gets a little bit worked up with that, because what I'm talking about here is what we did recently. So this was a study we published a couple of years ago where you press the button and stuff happens and you get that. When Heidi did her PhD, she didn't have the buttons to push on the computer. She had to analyze every one of these EEG channels individually. And she only used 4, but how long did it take you to analyze one set of EEG there? About 7 months. So Heidi would sit there looking at this data, kind of with a ruler or something, and screens. And if you've ever seen Heidi, when she's working on a computer, brilliant lady, not so much with the computer. So I was telling Imran before, I should hurry up, but one time I went to her house and she was reading a PDF, and it had been sent through, it was the wrong way around. She had her computer on its side so she could read the PDF, because she hadn't quite worked out that there was a button you could push to turn it around. But anyway, back when Heidi did her study, you could only use a few electrode channels, so 4, 8 electrode channels, and it took an awful long time to do an analysis that we can do now more or less straight away, maybe within half an hour. And we get these squiggly lines, And Bernie was talking about the squiggly lines. You got the stimulus here, and then these numbers, that's how long it takes for that afferent volley to travel through the nervous system, and the bigger the number, the further it's gone through the nervous system. So Bernie talked about an N9. That would be looking at the afferent volley as it gets to, say, the brachial plexus, or an N13 could be in the spine, N18 might be at the brainstem, and as you get further along, say N20 and beyond, that's more what's happening there in the brain. And if we look at the early work that Heidi did, one of the key things that they found was a change in this thing here, which is the N30. And this was quite a cool finding. It was a very novel finding because what it meant was the N30 is associated with early sensory motor integration in the brain. When we adjusted someone, or when Heidi adjusted someone, we saw a change in this N30 amplitude, which suggested a neuroplastic change in the brain following a chiropractic adjustment. And that was a novel finding. It showed that we changed the way the brain processed sensory information by adjusting someone. And Heidi published these studies. Here's some of them here, and tended to win lots of awards because this was really novel work. So back in 2007, that was the first publication, and she repeated that, published more studies, found the same stuff, right? Which doesn't always happen in science. So we had these studies starting to come out that showed a change in sensory processing after an adjustment. That's a really cool thing, but we wanted to know a little bit more. So actually, looking back here, I've got a photo here. This thing at the back here, that's the equipment Heidi was using in her original studies. We kindly call that Frankenstein. And it's about the size of a small car. We keep on saying, can we kind of clear it out of the lab so we have more space, but she won't let it go. But using Frankenstein, you could record 8 channels of EEG. So Heidi was doing 4, too lazy to do the other 4, but you could use Frankenstein. Sorry, it would have taken her 14 months to do it all. Anyway, using Frankenstein, you could record these 8 channels. These days, the equipment that we use, so going back to this thing here, you can basically, it's about the size of a large book. So the equipment that we use now, you can record, say, 64 channels, and you could fit that equipment in a backpack. And the other thing that you can do with this equipment, if you're using 64 channels, is you can kind of triangulate down so you can work out if you see a change in brain function, if you see a change in sensory processing, using these 64 channels, you can tell where in the brain that change occurred. And we thought that would be a really cool thing to do. We wanted to do the study again so we could look at using this modern equipment in a lab run by non-chiropractors, which we thought was another important thing to do. Using this flash 64 channel system, would we get the same sorts of findings? And where in the brain were those changes taking place in somatosensory processing? So we did this study, which was published a couple of years ago, to look at that. So again, previous findings, chiropractic care causes a reduction in the amplitude of the N30 set peak. We wanted to know, can we replicate this finding, and what brain generators are responsible for this reduction or this change in set peak? So in this study, we had 19 subclinical volunteers. So again, you heard about the subclinical pain patients. That's what we used in this study. And we looked at these set changes either before and after a chiropractic adjustment or just a passive movement control. And we actually looked at 62 channels of EEG. We wanted to look at the peak-to-peak amplitude, so how big these peaks were. Did we see a change in these peaks? And we wanted to look at the brain sources underlying any changes in these peaks. So here's the squiggly lines that we got when we did the control session with them. And basically this is the N30, so you got 10, 20, 30 milliseconds here, and we're looking at the amplitude of these peaks. This is pre, this is post. I'm colorblind, but that kind of looks like maybe a blue and a red line. and they're kind of the same. So after the control intervention, no real change. And this is one of the traces of the squiggly lines after the chiropractic intervention, and you can see here pre and post. So we had that decrease in amplitude of the N30 peak after the chiropractic intervention, which showed, a change in early sensory motor integration, change in the way that we process that sensory information, which was cool to see. Doing it in this lab with Dina, when we first started doing these experiments, Dina thought we were just a bunch of quacks, and why would we see any difference here? She was scared of chiropractors. She thought that if she got adjusted, she'd have a stroke. And after talking to Dina for, over about 2 years, working with her doing these studies, getting her horrifically drunk a few times, we convinced her to get checked, and by the time we left after the second time we were in Denmark, every day she was, can I get checked again today? She actually became a chiropractic junkie. But anyway, when we were doing the study, Dina didn't care what we found with it. She was not a chiropractor. She did all of the analysis, so about all we did was help by doing the adjustments. So we sat in the back seat as Dina took the stuff and ran with it, so she didn't really care what we came up with. But we had that finding which we were kind of expecting, but it was very nice to see that that happened in someone else's lab and not just our own. So N30 peak amplitude, after the chiropractic care, we had the decrease that we thought we were going to find. But we also wanted to have a look and see what areas of the brain changed. So what areas of the brain changed when we adjusted someone with respect to this N30 peak. And what we found, which was really interesting, was it was the prefrontal cortex was the area of the brain that changed following the chiropractic adjustments. So we thought that was a really cool finding. We didn't know what to expect here, by the way. Didn't know what was going to come up. So prefrontal cortex, we thought that was really interesting based on what the prefrontal cortex does, which is all sorts of stuff. The thing that we associate with it most is the executive function. So taking lots of information and helping to guide goal-directed tasks. But also you see changes, it's associated with memory and attention, intelligence, processing of pain, autonomic function, motor control, eye movements. We're starting to get into some eye movement research in New Zealand. Bernie's already doing that over in Canada. But all these sorts of things that we see in practice when we check and adjust people, we see changes in these things, but we haven't really known why that might be. Perhaps it's because when we adjust someone, there's a change in the way their prefrontal cortex works. So, cool thing from this, it also explained lots of the findings we had from other research that's been done. Things like joint position sense maybe, reaction times, cortical processing, sensory motor integration, reflex excitability. Maybe this is because of a change in sensory motor integration in the prefrontal cortex. Last couple of things here just to finish off. I'm not very important, so I don't get quite as long as the flash people. But lower limb muscle strength and motor control. So Imran's coming up next. He's going to be talking about some of the research that we've done in this area. And then Kamal's going to finish off by going into a bit more depth looking at motor control. But one last thing, just got to acknowledge the people who give us money. So ASRF, Hamlin Trust in New Zealand, we couldn't do this stuff without them. So thank you very much.